Okay, so in this video, I'm going to be going over a part of the network architecture for a game that I'm currently working on. And specifically, it's going to be the part of the networking architecture that's responsible for handling actions from a specific player and synchronizing that between all the other players. And so the network protocol that I chose for this is WebSockets, which WebSockets is essentially let's get a little thing going here. WebSockets is essentially a protocol that is bidirectional, and it's a persistent open connection, and it can be used to basically synchronize data between lots of people, like with a chat app or something. Now in this case, I'm not making a chat app, although you could say that could be a subset of the game, because a lot of games have that. In this case, I'm more focused on the game state, the game data. Sockets is a little bit non-intuitive to use at the beginning. In the very most simple base case, let's create a little bit of a server here. This is, let's say, our edge server. We're gonna make this distinction because it becomes important. We'll give this a color and just do this really quickly and stuff. And then this is our Godot client. It's what most people would call the UI, right? It's a thing people get in Steam. And more of these. Okay, so we've got this guy, and this guy inherently, like in any server thing, he basically talks to this guy. Well, we actually have a bunch of these, and this is what the game is. It's a multiplayer game, and all of them are talking to this guy, right? And so the key here is when one of them changes the data, this one is gonna send back to all of them. It's going to send back the response as well. And so every time the data is changing, or at some rate, they're being synchronized. This works up to a certain point until you have like a bajillion of these guys. Once you've got like 1,000 players, you can't have them all connecting to one server. So what you end up having to do is have multiple different types of servers. But the problem then, once you have all these different types of servers, so you got these guys and they're actually connecting to different ones. They're not connecting to the same one. And it's random how this is happening. Because let's actually make this even more accurate, because there is this construct in between them, which is just, what the fuck? Okay. This was set up a lot better, I feel like, before. Okay, this is how you get all the good colors, okay? This is DNS, and DNS is effectively, for those that aren't aware, everything happens on the internet through IP addresses and other stuff like network address translation, which effectively gives you a whole lot of different ways to route from one thing to another thing, as long as you've got like a path in the entire network graph. Now, it's really hard to remember all of these esoteric 3-digit numbers. So what they do is they use DNS instead, so you can take a name and then map it to that. And DNS is a really good system, but it's also a really weird system to work with, because if you try and make a change to DNS, you have to literally wait a day or two sometimes. You gotta wait a long time, comparatively speaking, to other stuff for it to actually propagate. So anyways, all of these guys are actually going to DNS. And you could make this a load balancer, but a common theme you'll see with a lot of my network designs is that I pick something specifically because it's cheaper, because I'm gonna have to pay for all of this. And this is one of the problems with a lot of the system design stuff out there, is that it's focused on an ideal situation, and it's not focusing on the pragmatics of paying for every single thing that you're adding to your entire architecture. So anyways, you've got this DNS in front of this, and then it is gonna take each one of these and randomly route it to this stuff as well. Now, this is obviously a problem, because if the state is captured all here, if, player's game, blah, 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 is here, and they make some sort of change to it, A is 10 now, on all of the other servers, this isn't the same. Maybe it was still 5 over here or whatever. And this is because these servers don't have the same concept. They're not stateless in a sense, which is what you're usually trying to do for a layer like this. is to not have this state, but it's like fundamentally against the entire concept if it's a WebSocket a lot of the time. So there's a lot of ways to solve this, and probably the one that I chose is effectively what you do is you have another layer after it, which in my case is called, I named it, it's something that I worked on a long time ago. Let's just go with something like this. So this is now a layer behind all of these, and it's actually responsible for, and you can shard this as much as you want too. You could have multiple ones of these, and then of course like some of these whatever would be going to it as well. The key here though is that all of these servers are connected to every single one of these anchor servers. And the anchor servers are actually, okay, fuck that, whatever. Let's do this. This is gonna be necessary too. Let's just come here, make it a little bit cleaner, but let's get a little bit more clear with how this is probably gonna be. Get a little bit of proportion here for what might be happening. So there's a lot of these things. There's a bunch of these things. There's less of these things probably. But these are the things that similarly are going to be handling the actual writing of data. And they also are going to be using WebSockets. So let's just add that here. This is WebSocket. Between here, between these UI clients and these is WebSocket/HTTP. Okay? They basically are interchangeable in a sense because any like post request you make can just be sent through a WebSocket. The main difference is that these things send data back to these guys sometime periodically being like, hey, why don't you go and update your data again? So anyways, this is not DNS now. This is actually something different because these are going to be responsible for actually writing the changes. We're going to use a shard key here so that it effectively goes to one and only one of these things. Okay, so let's take a little step back here. Let's say in my game, which is like Super Auto Pets, a player, let's say he has a team. I'm gonna go with just a really basic JSON data structure here. Say he has a team and he just added an ant to it. Yeah, I want something simple. He's added an ant to it, right? How is this going to flow through the system, more or less? So it's going to start here, and then he's going to be like, all right, he connects to one of these servers, and then one of these servers is going to, using a key that for this, the key they're going to probably use is something like, maybe his username is user1. And so they're going to take user1, and, or let's get more specific, user1, run1. So this is part of his run data, and this is his user. And that's going to take all this data, and it's going to effectively go to one of these anchor servers, right? And the whole purpose of the anchor servers, and this is also WebSocket over here as well, WebSocket and HTTP. Let's just move this. So yeah, the whole purpose of these anchor servers is to make writing a consistent and concurrently safe operation between every single player. And that's the main purpose, but then the secondary purpose is to allow more players to be synchronized at the same time, because all of these players can connect to this layer, right? They can connect to this layer, and this layer can be larger and have more open connections that are theoretically possible, while this layer can have less, but since it's actually doing the state modification, what it can do is when a state does get changed, it can come and notify effectively all of these. I think you can curve this sort of. So it can go there, and it can go here, and it can go here, and it's like effectively all of these servers are connected to all of these anchor servers. It's a pretty bad demonstration, but whatever. So every single, this one's connected to this one, and so is this one. And so when this one changes this data, that's its shard, that it's uniquely responsible for, it comes back, it notifies all of these, and then these ones come back and notify all of these guys, right? And by the end, you've got a system that has two main properties. The data can be concurrently written to, and it preserves consistency. So no matter what anybody reads, it will always be the latest data, but it also allows it to be synchronized between 1,000 people or something. And so you can see there's two main layers here that both use WebSocket, HTTP, and DNS to go to the specific edge server, a shard hash key to go to a specific anchor server. I'm not going to really get into the database layer here, but that would be the final thing over here, is effectively something like a Mongo database. And you have the same kind of general pattern where you have a bunch of these and you're going to shard to individuals here. But it's a little bit more complicated. Here, we simplified everything to, this is just one JSON object with some data that needs to change. We're going to send it here, and then everybody else is going to eventually get this all the way over here again. And they're going to get it effectively by reading from MongoDB too, which I guess is the last thing. These guys are responsible for sending write requests to Anchor, and then they're responsible for sending read requests basically to MongoDB and getting that data back and then sending it to the client. And that data in this case is these two things. So this is over here, comes over here, got changed over by this guy, was in here. MongoDB changed it. MongoDB doesn't notify anyone of anything, but because this guy is the only guy who can change it, he notifies all of these guys notify all of these guys, and some of these guys will be like, I care about that data, I'm gonna go get the latest, and then that'll come this way. So at a high level, that's like how WebSockets is working in my system. And let me know what you think about that. I'm going to probably continue doing some more of these videos going over maybe parts of this graph with a lot more depth. But yeah, anyways, that's what I have for today. Thanks for watching.